Locks was inspired from my development in trying to store credentials, keys, API things, passwords for databases and other things in software, and not happy with solutions that were out there, such as storing those in the code so an attacker can just read it and pull that information out, putting it in the environment variable or a config file and getting the same problem. So after a while, this module represents some of my best research and efforts to come up with something that will help the industry. So it's called Locks, and I wish I had a cool salmon logo, but I don't. So for now, this is how it works. So Locks is either a library that you can call. It's C callable. The code is available to link against. So if you know how to write C callable libraries, I would love to expose this to Python, since many of you use Python. But the idea is that it will pick the best kind of keychain, keyring, TPM, HSM to guard the secrets depending on what it can pick up on the system. And it will allow your program to access it based on whether the user has authorized you to access the keychain. And then the operating system will guard it as it does, and that way you don't have to worry about the program being as secure, because now you've basically pushed the security out to the operating system. So here's how it works. For our demo, I've created a command line tool that allows you to insert secrets, pull them out, or delete them from the keychain, the operating system's keychain. I'll expand it for other operating systems, but for this demo, it's just running on the Mac one. And so Locks, for example, I want to pull out some AWS API keys that I've put in there. And it says it can't find it. Now, right now I have my keychain unlocked, so I'm going to lock it. So this is normally what would happen when you first try to access it. So each keychain has some credentials that's whether locked by the operating system, whether it's a biometric. In my case, I do not have biometrics turned on, and so I'll just enter my keychain password, and then Locks is able to access it. Now, let's say it was locked again, and an attacker didn't know it. So he tries to enter in, it just keeps giving him no, and so he has to cancel out, and then it just says, sorry, you can't get access to the OS keyring, you're toast. So that's kind of nice, but in my case, I know what it is, and I need my program to get access to it, so I need to access the keychain. And I go, oh, it's not in there. So let's put it in there. Now, if you've ever dealt with keychains require two things. The first, they want to know the name of the program that is putting the secret in there. For the sake of the demo and simplicity, I just am passing it as a command line parameter and not having Locks figure it out on your behalf, which will be an improvement later on. So let's just say the name of the program that's accessing it is AWS, and the ID for the secret is the API key. And so Locks says, all right, put one in. Now you notice I didn't provide one, so it's sitting here waiting for me to enter one. So let's say it was in the CSV file, so I'll just put in a value right there. Yay, great, it was in there. And now if I run this again, I can see the same value I just put in was there. And now whenever my AWS program, whatever that happens to be, whether it's a Python script or a PHP program, WordPress, etc., it would use this service name to pull out its secret. And then and this is public information, right? It doesn't matter if an attacker gets a hold of this. If he can't access your keychain, there's no way he can get this out. So if I start running my program as my user has access to the keychain, then that can use it. So as long as the attacker doesn't compromise my account and get or manage to sudo to my user, there's no way he can get to the keychain to pull out my secret. And any other programs I might choose to run with the same service name or other service names, it doesn't matter. I could insert others. So there's AWS. Let's say you're an Azure program, right? And that has an API key. And so let's put another one in there. This could also take a cryptographic key. I'm just doing API tokens, right? So then my program that's running the Azure program, whatever it is, it's C#. The first thing it could do is it could use the locks C callable library or this command line tool and just pull it out and read it into a temporary or a private variable. And it could even encrypt it in memory if it wanted to, and then, or heck, it can only pull it out when it absolutely needs it, then to wipe it from RAM, and away you go. And your secrets are safe. You don't have to worry about wiping them from the command line or anywhere else for that matter. So anyway, that's all there is for now, and I hope to expand on this and make it better so that other operating systems and other methods can store their secrets and be able to take advantage of this great tool. So let me show you how it would go to delete it. So I'm going to be able to delete the secrets when I no longer need it. So delete it. Now if I try to call it again, it'll say, sorry, it's not there. And Locks is a Rust program, so it is a binary. It can run on any operating system as a compiled program, and doesn't need any interpreter whatsoever. So you can compile this and stick it in your computer binaries directory. It also has libraries you can link against. So right out of the box, if you wanted to, this file right here could be linked for iOS development and would automatically call the appropriate key store for storing secrets. And the only thing you have to do is call the API that I have conveniently written. That removes a lot of the headache and frustration and potential misuse. So anyway, that's it for now.